Click the bell icon to get latest videos from Ekeeda.
Hi guys, welcome to Ekeeda and I welcome you to this lecture on analysis of RC circuits problem number 7. Let's see what this problem has for us. Well, you can see here in the network below, means in this network, capacitor has now initial voltage. Now this problem number 7 is much similar to problem number 6. I can show you problem number 6. This was the problem number 6 that we did. The same problem we are taking, but now our capacitor had some initial voltage. So that is the difference. Now this capacitor has initial voltage of 10 volts and at time t equal to 0, this switch K is closed. We have to determine this current. So majorly this problem will be similar, but only thing is there are some initial conditions. So we will solve those initial conditions and rest will be a work for you. Obviously we will get the complete solution, but the in between labor work we will avoid it. So let's start with this, and the first step is to get the generally it is to get the differential equation, but here because there are initial conditions given on capacitor, we should be able to find what is the initial current, because once we know that initial current, in the last step when we have to calculate the arbitrary constant K, it is required. So what we will do, it is given that this V2, or I will call this as V2 equal to Vc, and it is given that this Vc of 0 minus is equal to 10 volts. It is given to us. Now what I will do, I will apply KVL to this circuit, and at t equal to 0 plus, so 0 plus means just switch is closed, and I know that when this switch is just closed, this capacitor will act as a voltage source. So at t equal to 0 plus, what is going to happen, this switch is going to get closed, this source will be active, this resistance will be there of course, and the capacitor is to be replaced by a voltage source of 10 volt. So you can see I have drawn diagram. We had a lot of practice of such diagrams when we did transient analysis, the first set of problems. Now this is the source voltage, this is resistance R, the value of resistance R is same, 10 ohms, and the capacitor is now replaced by a voltage source of 10 volt. So now if I apply the KVL, what I will get, V of t, this resistance multiplied by current, and because I am going this way, that is clockwise, this is going to be minus 10. Now I want to get current. Well, this is, I have not written here, it is I of 0 plus. So in order to get current, I will take this term to right hand side. Well, one thing is we have to evaluate this at time t equal to 0 plus, because we are doing everything at time t equal to 0 plus. So don't worry, we will do that. Now I got this 10i equal to V of t minus 10. So t is equal to 0 plus or 0, and we know the value of V of t. The V of t is nothing but 10 e raised to minus t sin t u of t. So this is our equation now at time t equal to 0 plus. This t is nothing but 0 plus. I also is at 0 plus. So now when I substitute t equal to 0, sin 0 will become 0, and then this complete term becomes 0. So 0 minus 10, or it is minus 10, and so I of 0 plus will come as minus 1 amperes. So this is the only important part, which is, I guess it is different. Rest part will be same. So initial current what we got equal to minus 1 ampere, and now our next job is to get the total current, which is of two parts, one is complementary and one is particular. So we will get that, we always know that total current is I particular plus I complementary. As usual, step number 1 to get IC, To get IC, you need a differential equation. So for that, you need a circuit. So this circuit will be modified now. So I will draw that circuit. You can see here, I have drawn the circuit. I have not written the values of elements. And resistance is of 10 ohms, capacitor is 10 microfarads. So a capacitor is now replaced by a voltage source of 10 volt as well as its own value. And when you apply the KVL, you will get the differential equation. Well, you can see here u of t term is there. U of t means a unit step signal, and when you are solving it for time t greater than or equal to 0, its value is always equal to 1. So there is no need to write this u of t signal. So now if I apply KVL, I'll get v of t minus 10i minus this 10, and then the voltage across capacitor, that will be minus all equal to 0, and then I can substitute instead of this v of t as this minus 10 I can take to right side. Capacitance value is 10 microfarads. Now here I don't want this integration sign, because so I will differentiate this equation. After differentiating, only I will get a differential equation for which I have some standard solutions. So I will have to differentiate this equation with respect to time. So when I differentiate it with respect to time, I can take this term also to right hand side, by the way, because this is actually my source. Generally source should be written on right hand side. So here I will have to use UV rule that we will use. Here it will come 10 di by dt, and here integration sign will vanish. And because here it will come 10 di by dt, and I should make the coefficient of di by dt equal to 1, I will divide throughout by 10. So after taking the differentiation, I will divide throughout by 10. So I'll take differentiation of the first term. I'll take it to right hand side in the next step. So here, this first term is what we have taken the differentiation by using UV rule, and it is e raised to minus t cos t. Then this minus comes because it is derivative of e raised to minus t is e raised to minus t multiplied by minus 1 and sin t. Then minus 10 di by dt. Then minus I upon 10 microfarads. And differentiation of this constant 10 will be 0. And now I will divide throughout by 10. So it gives me here so if I take this term on right hand side, or what can I do? I can take these both terms on right hand side. I have divided throughout by 10. So this 10 is gone. This 10 also is gone, and here 10 square. So 10 raised to minus 4, that goes in numerator, becomes 10 raised to plus 4. Both terms are now positive. So you can see this is the equation that we have got. This is the problem which is similar to previous problem. So I will show you that problem. So in problem number 6, we had similar problem, same circuit, but there was no initial condition. You can see that. So we solved accordingly. You can refer to that video if you want. I will just show the differential equation, and you can see here this equation number 1, di by dt plus 10 to the power 4 into I is equal to e raised to minus t cos t minus e raised to minus t sin t. And if you see for this problem, that is problem number 7, the same equation we have got, di by dt plus 10 raised to 4i. So it is di by dt plus 10 raised to 4i, e raised to minus t cos t minus e raised to minus t sin t. minus e raised to minus t sin t. So from here onwards, I will not repeat it. It will be same as problem number 6. So I will just explain it. As we know that total solution is particular solution plus complementary solution, and the first step was to get complementary solution. So to get complementary solution from this equation number 1, we make this right side or source equal to 0, and by doing that, by making that source 0, I got a equation which was homogeneous equation, and then I compared with standard form, and then I got a solution k into e raised to minus 10 raised to 4 t. We will require this because now this constant k will be different, because now initial conditions are different. So we'll keep this page little bit aside. Now the trial solution that we have chosen is this: a into e raised to minus t cos t plus b into e raised to minus t sin t. And the reason why we have chosen it, because the right side of our differential equation is of exponential and cosine form. So this is obvious choice from table. I can show you the table. The exponential and cosine, so it is having this form, cos plus sine. Always see it is plus there. So exponential cos plus exponential into sine. So by choosing that solution and by substituting it in the original differential equation, that means this one, because once you choose a solution, you have to substitute here. When I substitute it here, I have to take its differentiation, and then once I solved it, I got these constants a and b. I have solved it. You can refer to that video also. So after solving a and b, the constants, obviously in this case also constants will be same, and this will be our particular solution, and total solution will be this. So we will be copying this total solution as it is, because it is going to be same. After this step, see here t equal to 0 plus current was 0, but our current is minus 1 ampere, so that we will substitute here. So this is the equation which we will take as it is, this equation. So I'll write this equation for this problem number 7. And now you can see, now if I want to get this value of k, I will put initial conditions. So at, this is the difference, current is minus 1 ampere, so this minus 1 will come here, and you put t equal to 0. Here sin 0 will become 0, cos 0 will become 1, 1 minus 0 will become 1. So it is going to be 10 raised to minus 4 into 1 into 1 minus 0, that is again 1, plus k into 1, or k is going to be equal to minus 1 minus 10 to the power minus 4. So that we will calculate. So that comes to be minus 1. So the k value is minus 1. So again we will substitute it there in the original equation. K is minus 1, so minus, and that's all about our solution. So this is all about problem number 7, which was similar to problem number 6 except some initial conditions, but such complications do come in exam. So thank you for watching this video. Please subscribe to Ekeeda. Thank you.